All right, how's it going? Good morning, everybody. Back to another episode of Digital Iliad here. The place where we tell ourselves we're not making an ECS while we make an ECS. Because that's kind of what we're doing, and that's probably what we're going to be doing for the foreseeable future. At least the next, couple of weeks. All right, so we're settling on what our I want to avoid boxing. I want to avoid boxing when we're comparing our entities. So should we say, should the equals, do we specify that for the other t where t is an identity? Instead, should that be for other t where t implements I-equatable identity? Is that better? Because that lets the comparison happen directly on the In which case, is the interface even really necessary if this is all the interface does, which is specify a way for the entities to compare each other? Yeah, that's all an identity is it's just a thing that implements I-equatable identity. I think that's all we need for now, as far as the definition of the entity here. We'll need to override some stuff for each one, but that's fine. We're trying to avoid any kind of inheritance. We also might go and change our managers to be called systems again. I don't know. I keep going back and forth on how like full-on ECS we want to be about this. Or how much I'm kidding myself. Similarly, I kind of want to make this abstract class manager just be an I manager and also not have any... I don't like inheritance. I mean, if I need inheritance, shallow inheritance is fine. Hey, Connor, what is an FTL-like? So an FTL-like, if you are familiar with FTL, which fair enough, if you are not, FTL, let me find FTL, faster than light. That is a roguelike space game. That is a roguelike space game from 2012? Yeah. Where you command a little ship, a little spaceship. You fight other spaceships, you go on adventures, you manage your crew. Your primary functions are to manage your crew and your systems. So these little icons that may be gray or orange or red, they control like your weapons, your shields, your engines, stuff like that. And you have these little crew members. So you direct them around, manage your systems. You manage the power distribution of your ship. That's the bar in the lower left. So it's kind of this Star Trek kind of simulator game. FTL was originally like a flat 2D kind of thing. We're kind of heading into a more isometric 3D kind of thing, a pseudo isometric, kind of going for this kind of look. This kind of side-on, kind of almost pop-up picture book look. So we've been working on how to build ships in this. And the ships in this game are going to be kind of more vertically stacked. They're not going to be those flat top-down 2D things. So we've been working on a tool that lets us build these kinds of ships. So like I can place a top deck here. That'll be the roof. I can put some walls up underneath here. And you'll notice that if I cover the whole area, it becomes a compartment. It changes color because it's fully pressurized in here, and we can add some doors. So we can build these 3D ships. We can even rotate them. So there's kind of this structure. It's a pretty primitive tool set so far. It's kind of the main thing we're working on right now. But we're trying to make a game that's kind of like, what if you were the commander of a starship? It's awesome that you're using Godot and C#. You think using C# is underrated in Godot. More user-friendly than Unity, in my opinion. Really appreciate that comment as well, that you like it. I agree. When I picked up Godot about a year ago, I wanted to learn gdscript. I specifically did my jam projects in gdscript. I did the initial prototyping in gdscript, like this is all running in gdscript. But now that I want to do the kind of this more complex kind of simulation stuff, I've kind of split the code base into 2 different sections. So there's like there's the gdscript side, which the gdscript side is going to handle UI and rendering. And pretty much that's it. And the C# side is going to handle all of the simulation stuff. Like the gameplay simulation, you know, building these things, basically all the stuff that runs on pure data, the stuff that we don't need to render is going to all be handled just in C# land. So we're kind of coming up with a new framework for how we want to do that. Yeah, this is a really janky tool right now. We can't really build anything other than a flying housing block, but we'll work on that. That'll be the next thing we work on. But yeah, I'm using C#. Right now we're kind of building out our own little ECS kind of framework. Since we're not going to be in object-oriented land, we might as well do our own thing. We're not going to need nodes, like our scripts aren't going to be backed by nodes and things like that. We might as well do things a little differently. Interesting stuff. You get why gdscript would be used for UI and C# for data-oriented stuff. Yeah, that seems a natural fit for me, because, you know, the scene tree in Godot is great. Kind of the way we're imagining the flow of things is that, you know, we have like an input handler that's maybe an autoloader, and that sits at the top. I have a system diagram. Isn't C# completely object-oriented, though? Inherently, yes. But if we rely entirely on structs, pretty much, if we actually implement an ECS, we can kind of ignore that fact. But we still need to be able to interface with object-oriented stuff because we need to talk to Godot, right? So here's kind of an idea for how the system design will work. This is really rough, but this was like an initial idea. Let's say we have like our auto loads here at the top, like our input handler. Then we have our scene tree, and we have like this core game manager or thing that is hooked into the scene tree. It's part of the scene tree. It's a node. So that it can take stuff from the input handler, and it can, you know, it'll run our inherent, or like our built-in process function and stuff like that. And it will start driving the C# sub-managers, which are like our systems. So like we'll have a state manager, depending on what state we end up in. Like, are we building things? Are we playing the game? Like, are we acting? Is the game paused? Is the game running? What kind of build mode are we in? We might feed to a different manager down here, which feeds to like a ship manager, a crew manager, and then all of this stuff, all of the data stuff gets calculated. Then we end up at like a scene manager, and the scene manager will, you know, do what it says. It'll manage the scenes. The actual, like, the ship is on screen, so we need to render updates to the ship. We need to, you know, change the UI, stuff like that. And then these scenes, which exist as nodes in Godot, they'll have like mouse pickable UI elements and all that stuff. So they'll drive the input handler. And then we're just back at the top where the input handler is driving the core game system, or is sending input to the core game system, which is handling all the managers and executing those. So we're kind of trying to create a little parallel world where we can do this kind of stuff. It might be easier for you to use C, C++ if you want to go with structs. If you don't know C, C++ already, then it's easier to use C#. Yeah, that is true. It would have been easy. It would be easier for me to use C, C++, but I am more familiar with C#. There are some exciting things in C# that I am only now learning about, because I used C# in like Unity, in the Unity days, but it was an old version of C#. So now I finally actually have access to like the current stuff. So we can do awesome things like using the record struct, which are these new kind of code generated structs that are they're just faster than a plain struct. You get all this functionality for free. You can also override the stuff that you don't want, and you get some incredible performance benefits. Where's the diagram thing here? So like this. So like if we're using dictionaries, a regular struct is like, it's slow. Even if you override the hash, it's slow. But if you start using their record structs, stuff is fast. We're not allocating garbage. So C# has some exciting things. C# also has some other shiny tools that I want to dig into for newer versions. So I'm pleased with it as a direction so far. I'm also kind of more familiar with like an ECS mindset. It was kind of a weird jump to get into, to go into Godot. I come from the Unity side, and I spent the last like three or 4 years of my Unity time working with their Dots ECS tech stack. So that's what I'm more familiar with. This is still my first attempt to kind of make my own, what I'm calling like not ECS or ECS light, because we don't need a full, changing my scenes. Got the wrong window focused. But we're making a very simple implementation just for the sake of the game. Because a full ECS is really only useful if you're making a game engine, but we're making a game, we know our types. We don't have to worry about some nebulous user who's, who we don't understand and who is unknowable to us. So I don't know. It's a weird direction to go, but I think it'll be interesting. There are some challenges like this whole ship. Like the ship is kind of an entity, but the ship also has this buffer of blocks. So we need a weird system where entities can belong to other entities. So we need some stuff that's kind of unusual, like entity relationships. So I've been studying up on that stuff, so we'll keep working on that framework today. Pretty much everything I've been learning has been coming from this guy named Sander Martins, the maker of Flex. We have a weird little engine bug. But anyway, I appreciate you, Connor, stopping in, asking the questions. It's nice when I'm not just in an echo chamber here. But yeah, we're kind of working on how to structure our entities. I'm going to keep writing charts because it's helping me to write these diagrams. So let's say we'll have like an entity ID. It's going to make me make these two different words. Yeah, it will. Wish you could center the text in these cards. Doesn't seem to be a thing you can do, but that's fine. So we've got an entity ID. We'll have a version number. That's easy. That's straightforward. Can I align this on the other side? No, I cannot. Okay. Group these. So this is an entity. But it's not just this. We also need we need more identifying information than this. We also need like an archetype. So an entity will have an ID, a version number, and it also needs to have like an archetype. So we'll expand this, add another card. Let's add a card. Yeah, it is. We need an archetype. So we're going to continue to use the amazing things of this developer, Sander Mertens. Oh, Mertens, not Martins, excuse me. Sander Mertens, author of Flex, which does use C and C++. So probably would have been more natural, but I'm not familiar enough with that language to be confident using that. So for us, the interesting thing here at first is the entity index, which is the identifier for any unique thing. Could just be a vector of component identifiers, but a vector of component identifiers is itself like an archetype, like that's the overall type. We want to be able to have components within components. So we're going to have a system, we're going to make that part of it. So like here you can map an entity and its type to get the entity index. Because that's how you'd get the index into the type. You'd be like, I have this entity, it belongs to this type. Where is it? In the archetype. Ramsplug, what is FTL? Glad you asked. FTL Faster Than Light is a video game by Subset Games from 2012. These are the makers of Into the Breach. This is their first game. It's a kind of a Star Trek style game where you are commanding a spaceship, you are directing the movements of your individual crew members, you're managing distribution of power, you're repairing systems, and you are fighting hostile ships and kind of just going on space adventures generally. It's a roguelike, so there's branching paths for your ship to jump through, so you're exploring different spaces and trying to outrun this enemy. This is a top-down 2D game on a grid here. So we're kind of making a 3D isometric kind of variant of that. This is kind of a piece of concept art here that I drew up. This would be like a ship bridge. And we're working on some tools. Well, we're kind of moving a tool from gdscript into C#, but we've got a shipbuilding tool here. So we can build these 3D isometric ships here. Okay, interesting. How are you handling visibility? Like this, there's a cutaway system. Because yes, that is the big problem with doing a system like this. We're basically culling any wall that's beyond the mouse cursor. We have kind of a compartmentalization system, so you can tell whether a space is exposed. So this is all mid-tone gray because it's exposed to outer space. But this is all this light tone gray because our compartmentalization system can tell that these are like pressurized rooms. Very cool. Thank you. Appreciate that. Thanks for hanging out. How's your day going? So we've built this prototype in gdscript, but we want to do something that's a little more simulation heavy. So we're kind of heading more into offloading the game state into C# for simulation stuff, because we've already separated the game state from the rendering data. Like the game data is separate from the rendering data, and that's what lets us do things like rotate the whole thing. We can rotate this because, you know, what we're rendering is just a view into the game data. It's not the game data itself. Because rotating a isometric 2D environment is non-trivial. We can't really make anything decent right now aesthetically, but we're working on that as well. It's going all right, Slow Day at work, so you're working on game dev instead? Hell yeah. That sounds good. What kind of projects are you working on, game dev wise? So if we want to search an entity for a component, the naive thing to do is to just look for the type. See if it's there. See if the component has that type. Since we're defining an entity as... Our entity is both its ID and the components that it consists of. That like forms a single identity. Halo Forge meets Mario Party. Okay. Halo Forge meets Mario Party. That's a pretty wild mashup. Are you doing it in like a Godot in 3D? You're using Unity, but fully 3D. Awesome. So we're going to need an archetype, which is really just this vector of component IDs. The component ID is just the combination of components that makes this up. So it makes sense that we'll just use that as an archetype. And then you can map an entity onto an archetype with this lookup and get the index of the entity into that archetype. We need to sort these, which is pretty easy. This is in C, so they're kind of doing maybe a little more with vectors than we will, but so the component index is interesting. Are you solo or with a team? I am doing this solo. So I do the art and the game dev stuff. We've actually got some new art pieces that I want to implement. I want to put in these sloped pieces. And I also need to implement a zoom system so we can zoom the ship out and show it in miniature while still accurately displaying what it is. But our current architecture doesn't support this, so we're reworking some stuff as well. So I want to be able to draw more of an interesting silhouette. I still need to make some curved versions of these so we can have some more organic looking shapes, but I think starting with linear slopes is fine. Like these straight edged slopes here. So yeah, it's a little tough doing it solo because, you know, if you're not making progress, you know, if you're not working on something, nothing is happening with it. So this is presuming we're using a structure of arrays rather than an array of structs to store this, which is fine. I think that's reasonable. Oh, storing archetypes per component is pretty good. We can just check if a component has an archetype. That's smart. I'm using this resource from Sander Mertens, who is the maker of Flex, and I'm kind of relying on their system. I'm really interested in this, the entity itself. Because the thing that we want is we basically want a situation where like an entity is a unique identifier. We want components that don't necessarily need to be associated with data types, so we can have component tags. A component identifier is itself an entity, which is interesting. And an entity can have 0 to n components. These are also interesting. An entity component tuple can have 0 to n components. So an entity with a component ends up being like its own thing. So you can attach components to entities, and then you can attach, and that component can itself have components, which is kind of wild. And you kind of got to be careful about structuring it in such a way so that you're not processing things that way. Like if you have a component that has a component that is, you know, and the top level components attached to an entity, you don't want to process those nested components through the top level entity. You want to do it lower level, because you're treating, that's the interesting thing to me, is that the entity, so an entity has the components. Okay. This part isn't really the interesting part. A component identifier is an entity. This allows us to treat entities and components in the same way in many cases, and more importantly, it lets us add entities to entities. We want this. The Unity.ccs, I don't really think supports this. This is something that I want, because that was something that was kind of frustrating to me previously, that I was previously using with ECS, was not having the ability to add entities to entities. Made it kind of difficult. So that's definitely something we want. Also being able to add tags and stuff, and tagging entities for things that aren't known in advance, also cool. Making the most of ECS identifiers. This is kind of what we need to think about. So this person is using this interesting process where they're using the high bits to define things. So they're basically combining entity ID with version number. Like the entity ID is going to be the low 32 bits. The entity generation is a higher set of 16 bits. Like, I don't really want to get into that right now. I think for me, defining entity as a struct and for it to have an ID and a version number and to just do that as separate structs for now is easier for me and doesn't involve a lot of bit manipulation. Were we reading the old version of this article? Is this why it didn't have the information I wanted? No, this is just a different... This is about storage. This isn't what I wanted to read about. I wanted to read about this. So the interesting thing here, this is the part where component IDs or entity IDs. This is unique to me. I haven't seen people do this. But I'm trying to visualize in my head what we're doing, how we're going to implement this. And I guess it is really this simple. It's, you have the entity ID, you have the version number, and you have the archetype of the entity. Because then, and this forms a unique identifier, the combination of these things. And then so you could attach, like, let's start attaching things. Oh, why did it just grab one of these things? Grab all of it. So we could start, you know, combining these things in an interesting way. So like this entity. So this entity, their archetype are these two others, these two types of components. So you look at this archetype and this archetype. So the archetype and the type, the component type, I'm just going to call this component type. No, it's really the component set. It's like the component set. It's the set of components. So an entity keeps track of its component set, which is a little easier to think about than archetype. Maybe we call it set of components. And this is scalable, right? Because like I thought about a different system where like you actually treated these as different things. It was like really stupid. I thought of an architecture where you had, I used a chemistry analogy, which I think breaks down incredibly quickly, which is that like you have elements and an element is like an individual, like it's an indivisible singular thing, like position and scale or something like that. Like element A is position, element B is scale or something like that, or rotation or something like that. And then that forms a compound, which always has this combination of elements. But then you could combine compounds together to form a new compound. So you could have, this could be the position, this could be the rendering compound. Like these are all the parts that you need to render. These are all the parts that you need for physics. And then that forms a new compound, which is like, this thing has rendering and physics, and you can just kind of do that ad nauseum. And then I had a concept of like a mixture. And this is where you get things like tags. You get compounds that can come and go from the mixture or be in different amounts. So like a ship would be a mixture because a ship has all the things that a ship needs, like a body and systems and all that stuff. But it also has a crew, and it might have a different number of crew. It might have like many crew or few crew or something. And this is just stupid. This was like archaic to kind of try to, not archaic. Archaic's not the word. It was kind of overcomplicated. So I think doing something just simple and raw, like you have an entity has a set of components. That set of components contains itself entities, and just do it simple. Just don't make the distinction. Chris Page, are you planning to leverage the official Godot Rust bindings? No. Welcome to the chat. We're actually doing this. I know it's maybe misleading since I'm reading documentation that's written in C++, but we're doing this in C# because I'm more familiar with C#. I think ideally we would be doing this in C++. But you got to use what you know, and I'm more familiar with C#. I think trying to learn C++ while doing this project would be a little rough. But who knows, maybe we'll get there. I want to look at what his entity looks like without like diving into his source code, because it wouldn't help me. So we can kind of move on then, I think, to entity liveliness tracking. Entity relations. This is really interesting because this is what we want to define. This is one of the main benefits of doing it, where entities can have entities, because you can define the relationship of the entity. So you can say Bob eats apples. And so this entity is an archetype of eats and apples. So you can add compound components to an entity. And because they're compound, they can have a relationship defined between them. And you can use tagging to like specify that relationship. So you could say, you know, Billy is a child of Bob, because you put the child of and you put Bob in there, like, and you put Billy, and you're like, I don't know, I'm not explaining it well, but the one thing I'm not going to do is this combination of things. Adding entities to entities is cool. They're kind of using tricks with bit manipulation to do this, and that's how they're doing pairs. But yeah, this is a huge gain. If components are modeled as entities, adding relationships to an ECS requires no changes to your storage. That's pretty good. Fair enough, you were just curious. Rust is closer to C++. But if you already know C#, it might be better. Yeah. You're thinking about using gdscript and Rust together to build a game myself? Rust is closer to C++ than C#. Yeah, I think that's what you said. And yeah, that's correct. And I think that's good, and I think you can totally do that. What I'm doing is we've kind of got two different stages of this. So we're kind of doing this thing where we have, you know, UI, gameplay, rendering. This is every game, right? This is kind of the process of every game. It's just you process UI, you calculate gameplay, and then you render everything. So for Godot, we're going to use we're using like an input handler. Here, system diagram. We're using, like, in the auto loads, we'll have an input handler that can process key inputs as well as signal inputs from other scenes. So like mouse pickable nodes. That information will get passed to the game manager or main system or whatever you want to call it, which is a thing that's hooked into the scene tree as a node. It's like it's uniquely the only, it's like the bridge between the C# data land and the Godot node land. And it will process the stuff that it needs to from autoloaders like input handler, and it will drive the sub managers. So we can have a state manager that figures out what the game state's in, and that will trigger itself some different managers, which will trigger more managers. So it'll handle a cascade of running the appropriate systems for a given state. All the data will be processed, will funnel down to something like a scene manager, and that scene manager will drive the scenes. So it'll like update scenes, clean up scenes that don't need to be on screen anymore, add screens that do need to be on, or add scenes that do need to be on screen. So it'll handle all that stuff. And then once we have the scenes in place, which are, you know, the nodes, like a crew member running around or a ship that's rendering in front of you, all the mouse pickable elements can be hooked up to the input handler, and the UI can be updated and all that stuff. And then, so all of that stuff can be driven to the input handler, and then we're back at the top. So I think you could similarly do something very similar where you've very, very cleanly separated your Godot concerns, which is your UI, your rendering, stuff like that, physics if you need it. You could separate whatever stuff you want to run in the Godot scene tree from the stuff that you're running on the side, and it doesn't have to talk to each other, which is kind of why I'm doing it this way. You could definitely have a tight integration, and I think if you're doing C++, it's probably easier to make a tight integration where you're actually just running stuff through them, because gdscript can kind of sit on top of your C++ modules. For me, it's like more directly separated because I'm using C#, and there's some costs between going back and forth between C#, the managed memory of C#, and the you know, the native Godot stuff. So I have to be maybe a little more careful than probably you have to be to handle that stuff. Yeah, because you just link it to the into the engine. With Rust, you just link it in as a library. Yeah, exactly. So you're in a much better position to do that than I am. A question I have is whether their component entities are instanced, but I feel like they must be. Like it must be. Yeah. Okay. I think I understand what's going on. It really is what I've just described here, which it really is just. Entities can be, components are entities, entities are components. Entities are components, are entities. There's really no distinction between these. And I think that's kind of beautiful. You're unsure? You've never built a game in Godot? Oh, for sure. No worries. I've done some jams. This is my main project that I work on, but I do like to jam. I think if you're doing something small like a jam, it's probably easiest to just do it in Godot straight up and just use gdscript and stuff. But I think the bigger your project gets, the more tempting it is to do something else. So how do I want to represent the set of components is a more interesting question. They have it as a vector. And that's so they can hash it. Our set of components is arbitrary length. I don't know if I have access to arbitrary length vectors in C#. I think then I just use a different data structure. I think I just use an array or a list. Yeah, I just use a list. Or something like that. Or I can combine... I could combine some stuff. Cannot be used directly as an arbitrary length vector. Okay, well that doesn't work. Oh yeah, well you know Rust pretty well already, and so you just want to use it for preference. Yeah, fair enough. You'll still have to leverage gdscript for some things, even if you use Rust. Yeah, I think if you're doing it at a low level, you'll have a good time, because the gdscript really is optimized for calling into the engine. Vector of type. It's really good for. It's like really optimized for that. So. That's kind of also why I'm splitting it off. While I'm splitting off my C# and my gdscript stuff is because I can't call into the engine through C# as fast as I can do it in gdscript. So if I'm talking to the Godot API, I should be doing that mostly in gdscript. All right, so maybe pictures will help us here. Because I'm kind of curious about how we're storing this. And I've read through this, but I want to keep reading through it. So... Makes sense. Yeah. Yellow Frlansky. All right, I think I'm starting to get this in my head. I just need to decide how I want to store the component, the archetype identifier. The thing on the entity that says this is our archetype. Because an archetype is really just a list of component IDs. So like position could be 0, velocity could be 1. Maybe I don't want to use 0. Because I think here they reserve 0 for like an invalid entity. This is all about relations. Here we go. And having each component be its own entity does make it easier to do some things. It makes it a little weird to do other things. What are we learning? We're deciding on, we've essentially settled on this setup where an entity as a component is an entity. Like, I guess this is an entity as a component. They're the same. So you can build entities using components, which are themselves entities. So you have your entity ID, version number, you have your set of components. And this entity's set of components may itself be an entity with its own set of components. So this is how you nest things. So you don't just have to have a completely flat hierarchy. And this allows us to do things like entity relationships and all sorts of different stuff. And it allows us to process things separately. So you could say like, I want to process all of my physics stuff, all of my physics components in this like separately. It kind of lets us do... There's a little bit of indirection here that I need to resolve. How we handle that. Kind of limits the amount of data that I can put directly on the entity. Unless we just copy it a lot. Oh, you understand it more than me then. gdscript for the core. So you would probably use Rust for persistent, SQLite, and multi-threading concurrency stuff. Smart. gdscript for the core game logic. Also, Rust would be a lot nicer than C# for dealing things like bytes and vectors. Yeah. Oh, Chris Page, thank you for the follow over here on Twitch. I know you've been watching on the YouTube. Appreciate the Twitch follow as well. So yeah, I'm a little concerned about storing things, because the whole point is that this set of components will be stored in an archetype. And the archetype will have a list of its individual components, which would be these. But these don't know that they're in an archetype, because they have their own archetype. So they'd, in theory, be stored on their own list. So would we need like a bottom-up iteration somehow? I feel like I'm misunderstanding some of what Sonder is saying. Maybe the component ID is not per instance. Maybe the component ID is per type. Unlike an entity, in which case you would treat it a little differently. Then we need to resolve the whole, what if our component has components? Raw speed. Thank you for the follow. And thank you for getting us to the follower goal this stream. Appreciate you both. Feel like I'm slightly misunderstanding. So we're probably going to need to look at the pictures a little longer. Because, yeah, I've used ECS quite a bit. I've never had to make my own. That is its own goal. Yeah, that's it. That's it for Lansky. Never had to make my own, and it's turning out to be a little more complicated. Luckily, we don't need to do a full-on ECS. Like, we're not going ham here, which is why I'm hesitant to call it a full ECS. Because this isn't a game engine. We don't need to support arbitrary types. Like, this isn't for an end user that's going to combine things in a way that's totally unpredictable. You made your own ECS when you were using Love 2D. It's not as hard as it sounds. Yeah. That's fair. And yeah, we can ignore a lot of things about it because, like I said, we're not making a game engine. We're making a game. So we only need to implement insofar as it's useful to us in our particular situation, which our particular situation has some unique aspects to it. Like we need to be able to iterate over a ship and all of its blocks. So like this whole construct is a single ship, this area that I'm building in. And that ship needs to be able to update itself. Like it needs to be able to iterate through all of its blocks. And it is also considered an entity. I'm just kind of building stuff. So we need to think about that for sure as an important thing here. Keith, hey, just found you on your recommend on keep up the good work. Making games is hard and you're tough for taking that on. I really appreciate that, Keith. Thank you for stopping by. Yeah, we're doing some stuff. We've got some stuff. We got our autotiler shipbuilding tool, but it's very primitive and we kind of want to rebuild it in a different environment so that we can extend it more easily. And we're also thinking about our architecture. We're trying to split all of our game stuff from our rendering and UI stuff, and it's challenging, but we're getting there. And I really appreciate you coming in just to say that. Any of you on your own game dev journeys, I hope you're also taking heart. It is a long, difficult road, but there's a lot of us on it. So, oh god, I'm changing my scenes. I was like, what am I doing? I was like, my keyboard's not doing anything. And I look over at OBS and it's just like changing scenes constantly. I've never had that problem before, but now I've had it twice today. So I don't know. I'm just potato fingering this keyboard, I guess. Yeah. It's upsetting that we can only really make flying housing projects. All right, we got ads coming up in about a minute. We'll take a quick break. I'll do some reading, look at some pictures. I feel like once we answer some of these fundamental questions about how our entities and components are constructed and stored, it's going to be a lot easier to just start putting stuff together. We're doing the hard work, and I acknowledge that we're doing some boring work. So I really appreciate everyone coming in and hanging out anyway, even though we're definitely doing some of the more boring things that we could be doing, which is just flailing about. Yeah, I'm tempted to take this manager abstract class, turn it into like an I system, turn it into an interface, because it really only needs to implement a few things. I probably don't want it to know about the game. Change all this stuff. I might change this off stream. Some of that stuff about the managers, changing them back into V systems. I also kind of want to change my command structure, because right now they're a little weird. They're like just classes. Oh well, that's not what we're working on right now. We're working on entities, and we're about to go to ads, so we'll hang out. All right, here we go. 3 minutes of ads. For the on the YouTube side, we'll keep going, but we'll not cover anything too important, just so the Twitch people don't fall behind. So this is like all the info I want here. What I'm trying to understand better is the stuff about like what exactly is a component ID. Right, where each component ID is stored. Like, is a component ID really just the combination of components that makes it up? In which case, I think that's what it is. I don't think it's actually an entity ID. I think a component ID is just the components that make it up. No, but it needs to be an entity ID because we need to be able to find this set of components. Yeah, I'm struggling a little bit. Like it's easy to me to think about these shallow arrangements in the archetype, but I'm having a harder time visualizing how I'm going to store nested component arrangements. Like I get that we can do it, but because that's not been my experience in ECS, I'm having a harder time visualizing what we're going to do. Like all of the examples are just shallow. But to me, it's less clear what we do if position is itself like multiple components and a separate entity. Maybe I need to look down further at the entity relationship section. Sparse and dense storage, that is something that will implement relationships. So here's like an entity has an instance of a tag. Here's an entity has an instance of a simple component. Both examples add one thing, the component, to one other thing, the entity. Some components store a value, other components don't. Those are just tags. So now we're interested in relationships. We want to add multiple things. So this is just a pair of two things. So an entity likes dogs. Yeah, this makes sense. So this is itself a component. We didn't add the component likes or dogs. We also didn't add component likes with the value dogs. We added a component likes dogs, which is combined out of two components. Okay, this is the shit here. This is what I'm interested in. How are we adding components that are themselves components? Apparently that's something you can do in any ECS, but I'm having a harder time visualizing it. If you're in C++ or Rust, you're just one template or generic away from doing this, so you probably would be better off, but I think we can do it. Because yeah, these kinds of relationships are super good to be able to capture. Like player one attacks player two. That's it right there. That's the stuff. Yeah, because player two is an entity, so you can't just know what it is before the game runs. Rust. Kind of tempting, but I'm having a hard enough time learning a framework while making this game. I think learning a whole language would be a struggle for me. There's also a lot of people in Godot using C#, so I'm happy to be one of them. And I think it's a little more useful, or a little bit more community building. Yeah, because we're also interested in doing these hierarchies, like Earth is a child of the sun, Moon is a child of the Earth. You can even have values. Oh yeah, because this could have... Interesting. Data structures for storing relationships are exactly the same as for regular tags and components. Yeah. Each relationship pair corresponds with a unique component ID. Yeah, I think I'm getting what a component ID is wrong. Even though we treat them as an entity, I think they are themselves. If I want them all to just be, if I want those components to just be in the archetype and to process them within that archetype, it really is just that. It's not unique per instance, it's unique per type or per combination of types. I think that's what I'm misunderstanding about what a component ID is. If I had an infinite time, I would have figured this all out before I started streaming, but that's never how it goes, is it? I've actually been getting very little sleep because I've been kind of working on how I'm going to implement this framework in a way that makes sense for the game and isn't just like doing the most. Hey, Broheart, how's it going? I keep seeing your potato game updates, and it's looking good. People are soon going to be like, oh, like, you know, Papers, Please is nothing compared to your game. What's your game called again? Potatoes, Please. Spud Customs, nice. Yeah, that's great. That's great stuff. It's getting really popular in Korea and Japan. Okay. Nice. South Korea. Are you doing any localization stuff? Or is it just like the English version? Every language? Oh, wow. How are you doing that? I assume like machine learning, which is pretty good at translations. I feel like this involves hashing. I feel like instead of doing this ID packing that this person's doing with bits, I could be hashing things. And it would probably work fine. So their entity identifiers are 64-bit. I feel like I can just split this out. So the generation is their version number, the entity is their regular ID. So components are entities. That means they have this, right? This means that we can add entities to entities. Yeah, they have like a bit set. We could use a bit set, but we'd be limited to 64 components, which I don't really want to do. That's essentially what we're doing. Because both entities must be alive, we don't need the generation count. Yeah, that's interesting. You only need the version count for the top level entities, but you don't necessarily know which one is going to be the top level entity. I guess I would know. You're using a mixture of Claude, Sonnet 3.5, and Opus with copy editors for super cheap, less than $0.01 per word, $70 per language with full narration, and paid translations depending on where it is in the game store description. Fully human, 10 cents per word, slightly higher for Cyrillic and the Korean, Chinese, Japanese, $700 per language for narrative. Wow. So kind of a mix. You're using a mix, I guess, depending on how critical the language is. That makes sense. So the system that they use for entity and entity generation, which is this kind of mixed high bit, low bit kind of stuff. That makes a lot of sense. A component is nothing more than a unique ID with some metadata such as its size. Yeah. The unique ID is the type. Adding a component or a pair are the same for all the storage is concerned. It's just a unique identifier. Although the pair is quite a large ID, which the storage must be able to handle. True, because they're tacking on the pair to the upper ends of the 64-bit value. Effectively, what they've done is add another way of interpreting the identifier. Excuse me. So when it's a regular entity, it has a generation count. When you add it to an entity, you use the upper 32 bits to store an additional entity. Yeah, so this is a type ID. The component it's not an instance to it. It's just the component ID is its type, and its type could be a combination of components. How do we store that? Do we unroll it? Or do we presume that if a component's been assembled together, its pieces will always be processed together, and it's stored in the sparse table instead of the dense table? Maybe that's how you do it with compound components. Because you don't always need to use compound components. Yeah, I don't know about translations. I'm also using like my own font, so it's like the idea of doing a translation for it is really daunting because I'm using like my own like little font, which is not a great font. I would need to switch to something that was more flexible. I would need to switch to like silver or something like that. Or at least have the option of being able to render silver or some equivalent font. I don't even want to think about translations right now, but it's good that you're ahead of it, that you're getting ahead of it. So when you add a component to an entity, you use the upper 32 bits to store an additional entity. So that's the relationship. Interesting. Yeah, so they're using magic here. We can just create a clean break and just eat the memory cost of just having a separate field. But it does mean we need different types of things. We need to be able to distinguish like a component, like an entity relationship would be physically distinct from just a regular entity. Unless we use tags or something. Yeah, there's other things that would need to be added. Yeah, this ID partitioning space is really interesting. I like don't want to do it. We'll probably have more than 64 components, I feel. Yeah, so if components are entities, you can't make those kinds of assumptions, which is what I thought. ID partitioning is fascinating. This is the part that, oh, I see. I see. This is how they're doing it. They're using a range of the total possible values. I see. You're using a pixel font on the in-game documents. It's a headache to deal with the other alphabets. Yeah. I also have a pixel font. No worries. This is an interesting approach. And they're also using some bits at the end for things like tags, like disabled. Tag components. Maybe we need to consider doing this kind of bit manipulation. I really don't want to. It seems like overkill. Yeah, I'm getting hung up a little bit on the component ID thing, which I think is simpler than I'm making it in my head. I just want them to talk about that specifically more. I think I need to go to archetypes maybe. So he builds it up from a very simple data structure here. So let's just look through this and I'm just going to talk it out, and hopefully I resolve my confusion here by the time we get to the end. The simplest thing is this, where your type is just a vector of component IDs. And the component ID is just literally just a list of IDs, like it's just, or a list of numbers, one number assigned to each component. And so you would just look up an ID or an entity by its type, because the type is the window into the archetype, into like the list of all of the components for a given archetype, because you store those separately. So this makes sense. I get it so far. And its type is maybe shorthand for its actual component ID. Because yeah, the thing that I'm struggling with is if we add an additional layer. Like I get this seems fine, but once you start nesting this stuff, once you start nesting this enough, I'm starting to lose the thread a little bit. Like if we have this, Project Fluent. What is that, Chris? Looks legit, but I want to see what it. I want to ask what it is. It's a project focused on localization and is independent of programming language. Oh, cool. Let's check this out. Localization system for natural sounding translations. Oh, this is wild. So you can assign a gender to it, which is definitely something you need to consider in many languages. This is really interesting. Doing something like this is really interesting. My problem with something like this is I don't have the ability to scrutinize, like regardless of what translation system I use. This looks really cool though. Like regardless of the translation system I use, I have no way to scrutinize what is being written, really. Like, I mean, I could take the type and like literally throw it into Google Translate and see if it's like approximately what I want. But like that to me is the hardest part of doing this yourself, is being able to verify that the translations are like correct or good. But this seems really cool. I'm gonna remember this. They have an implementation in Rust so you could link your own localization library to Godot without AI. Very cool. Very cool. Hey, Leandro, how's it going? I see what you did there. I see what you did there, Leandro. You're omnipresent. You're everywhere. It'd be a lot of work, but it would be more user-friendly if done right, and would be free if you take away development cost. Yeah. Yeah, like for me, the quality assurance would still be a bit of a cost because I'd want some kind of verification that it was good, but also we'll see. Translation should never be an afterthought in a project, but that's kind of what it is to me at the moment. We're not ready to code. We're still trying to visualize this thing. I'm just struggling with this part. So we're gonna build it up. We're building it up little by little here, and until I have the correct understanding. Because the simplest thing is your type is just the combination of your component IDs, of all the component IDs on your person. That's your type, and you have your own entity ID, which is your, you know, I'm this entity. I'm a unique individual that exists. Oh, I think I just understand how this works now. I think I understand. So let's use some pictures to help. So if we're looking at a component that has components, where's the part of this that I want? So if we're looking at like if we're adding a component to an entity that is itself a combination of components, this is where you use the dense array versus the sparse array, I think. You mark that archetype. So if you have a compound archetype, you mark that as a sparse archetype or a sparse component. And then it's stored in the sparse array instead of the dense array. Does that make sense? So all of your simple components are here with the entity in the dense array. If you need to look up one of your sparse components, you map it to this sparse array, which will just redirect you. Does it give you a window into the appropriate dense array for that archetype? See, there's an indirection here. Maybe I don't understand it. That's the part that I'm confused about, is because if each archetype is stored and I want to look at the archetype for my component, for my for a given component, and I don't want to store it in two places, I guess it just becomes part of the archetype and it doesn't have a separate existence. I am making it too complicated in my head. It's simpler than I'm making it. You really just, so position, if instead of position you had movable, and the movable consisted of a position and, or maybe we say directional. It has a position and a direction, because some things can move and doesn't have a direction. So we say position, direction, or rotation or something like that. Maybe something rotation doesn't mean anything. So this component exists in the archetype for the entity, even though it's compound component, and its components also exist on this archetype, but then they can't be processed separately if we store them as a separate thing. That's part of my confusion, is how do we handle the nesting is really getting to me. Maybe like I need to be able to support the nesting, but I'm getting hung up on it quite a bit. Okay, let's go back to what we were doing. I love these streams where I'm just flailing about trying to understand something. Oh, Broheart, you redeemed the sit down, stand up, and I didn't notice. I'm doing it now. All right. Goodbye, cruel world. Goodbye, everybody. We're not ending the stream. I'm just putting the desk up. I just say goodbye because goodbye. I'm going off the screen. All right, now we got to deal with this. Now I'm down here. Now I'm down here and the stream is up there. What do I do about this? All right, here we are. I'm back. Sorry for the drama. I'm back and I'm standing, as was commanded. Sorry it took me so long to notice it. Nobody's redeemed that in like weeks. Rise. Yes. All right, so let's work it back up from first principles here. We need to know which components an entity has. This is simply done by just having a set of component IDs that together make your type. And then you can figure out your index into the archetype, I guess, by mapping the ID and the type together. Using the map. Or using that combination as your map. So a naive has component is just this. You feed in an entity and you feed in a specific component. So you look at our type You do all of that. That's not the right way to do it, and they're going to replace it with this. You have to store a vector per entity, which is expensive if you have a lot of entities, yeah. Second problem is that you need an ON search to see if an entity has a component. That's not great. ON is not great. So the archetype, this is our solution. They just gloss over what a component ID is, and I'm pretty sure a component ID is just a simple integer that you have once per component type. Okay, I think I am onto something with my thoughts about how a compound, a component that is itself an entity, will exist on its own archetype. It'll be stored on its own archetype. And if our entity, so if this entity, so this entity has one or more components, if we have to indirect to another archetype, like if our entity just consists of each entity that has its own archetype, then nothing is actually stored on the top level entity. And it becomes more and more expensive to access the different components because they're not going to be stored on the entity. They're going to be stored in their own archetypes. Which I guess that is how a structure of arrays would work. So I guess that's fine. It just becomes more expensive to process each entity because you would need to look. So if this is an archetype and if this is archetype A and this is archetype B and our entity consists of archetype A and archetype B, and then if I want to look at my component, archetype A, I need to index into that array. And that array is not... And it just keeps... that becomes unsustainable nesting down, because what if I need to look at a component that's in this archetype? Then I need to go... that's in like a sub-archetype. So like I have archetype C or something like that, which is a component of archetype B. Then if I want to look at that component, I need to go into that other archetype. And now I've just got indirection on indirection. And I feel like that's not how this works. But I'm struggling to think of how to do it in a way that that's not true. Oh, hey, Felice. Felice, you had a similar idea to implement an FTL-like adventure game in React.js. You're a web developer by training, and that's just what you're used to. But GD sounds interesting. Yeah, Godot is a good spot for it. Leandro, are we talking about ECS versus composition? Yeah, we're talking about... I love this idea of having an entity and a component being an entity, because then we can add components to components. We can build these complex things. I'm just trying to reconcile with that with the performance that we get from having a flat hierarchy. And maybe performance then isn't the goal, and it'll be performant anyway because we're dealing with some relatively low spaces. But yeah, Felice, we're working on kind of a cool dimetric FTL-like here, where we kind of got this low side-on, almost pop-up book aesthetic. So we've been working on how to construct ships that look like that. This is not the right scene. I'm like, why is this just blue? So we can build these ships. We have an autotiler and we have like an editing tool. So we can build these shapes out. And they're compartmentalized, so they change color. or we can track which ones are compartmentalized and which are just exposed to space. So this is kind of just for us. I don't know how much user-generated content I'm going to support in the actual game itself, but at least for us, this is going to be a way for us to build these 3D ships. And we can support isometric camera rotation, which is not easy. But we have some serious limitations with our current framework, so we're kind of trying to change it. And that's what we're bogged down in, is with thinking of a new framework that we can use. Appreciate that, Chris. Yeah, I really don't want to do any of this by hand, which is kind of why, hence the tooling here. I think tooling is super crucial, which is why I'm willing to spend the time here to come up with a framework that will be sustainable for us and extensible, because this needs to be... We're spending a lot of time on design, on systems design and stuff, but that's going to make the content phase of the game just so much easier to do. And because we're a solo developer, we're really going to have to, we really just have to take each phase as they come. Nice editor, thank you. Yeah, that's cool. An FTL-like adventure game in React is interesting. Yeah, and you're a web developer, so that makes sense. Similarly, I'm kind of a Unity refugee, so I have a lot of experience in C#, which is why we're trying to use C#, even though we might be better off just doing this in C++. It is. You mainly just build tools. Yeah. It's easy to get caught in that cycle of building tools and then just having a pile of tools and being like, "Where's the game?" But you got to have your tools, right? What 3D modeling tool is this? It is not. This isn't a 3D modeling tool. This is 2D pixel art, which I'm using tile map layers to render as if they were 3D. So we have our own autotiler, which is handling the connections between many different tiles. So it evaluates its neighbors and picks the right tile. So yeah, this is all 2D pixel art. It just looks 3D because we're able to view the game world from different perspectives. You do system programming? Yeah, that makes sense. Understandable to do what you know. You found this stream because YouTube can't stop recommendations that you already watched 11 plus years ago. Oh no. Yeah, I don't know why YouTube has started recommending me to people. I love it, but I don't know why they do it. But I'm happy. I'm happy that people are finding the channel. So yeah, it's going to be interesting. I don't know how much I'm going to let the player build their own ships, but this is going to be a really good tool for, at least for me, to do this stuff. What 3D modeling tool is this? Is a huge compliment to a 2D tool. Yeah, I agree, Furlansky. I feel very honored. You see someone doing something cool, he usually drops in to see what's up. Yeah, I appreciate that, Chris. I appreciate you hanging out and sharing your ideas here. I hadn't really considered C++ and Rust seriously, but I might have to reconsider for this purpose. I mean, I'll probably stay the course here, but it's a really interesting idea. Best 3D is no 3D. Yeah, Leandro. Yeah, 2D pixel art with the illusion of cameras. Yeah, that's kind of the illusion of the camera was a big trick for us, and it was kind of the catalyst for this whole let's separate the game state from the rendering state. Because if the game state doesn't care or know about how it's being rendered, it's really easy to achieve something like this. But if the game state is tied in with its rendering representation, like if the game, like if it's a node, or if it only knows how it is when it's on screen, like if it's tied into its physical manifestation like this, you can't do stuff like this. You can't just rotate the whole thing. Like I know a dev who implemented a simpler system to this, and their solution was to like literally have 4 copies of the tile map at all times, and they would just switch to the one that corresponded to the camera direction. But we're not doing that. We're like redrawing the whole tile map every time we change the camera movement. Or let's say the ship turns on its own. We need to support that too. Even if your camera doesn't turn and the ship turns 90 degrees, you still need to capture that. You'll be able to reconcile that. Chris, you had an interview with Cloudflare a couple weeks ago. Nice. For their data loss prevention team as a Rust engineer. You didn't get the job. Sorry about that. But that should give you an idea of where your interests are. No, for sure. I'm sorry you didn't get the job. They need some good people over there. Especially now. Oh, Cloudflare, not CrowdStrike. I did the exact same thing. I did the exact same thing for Lansky did. I got them mixed up. In the React world, the UI is a function of the state. Okay. Yeah, for us, the UI would be tied to nodes. So the UI is similar to rendering. The UI and rendering would be the glue, or the connection points with the Godot API, because we need to handle that there. We're having this engine bug. There we go. Let me get rid of that. It's not doing anything, but it's like clogging the debugger, which is upsetting. Yeah, never release on a Friday. It's definitely important. Yeah, for us, our hierarchy is going to be stupidly simple. Like you can kind of see it in the upper left. Like we have the game, and the game is the kind of root node and also the script that acts as the bridge between the two worlds. We'd have the board, which is a node 2D, and that'll hold all of the physical game pieces. And we have the UI, and obviously a camera, which we arguably don't need, because we're not really going to be moving the camera. And then our game here is a node. It's really the only C# script that implements this. And it takes in commands from the input handler, and then we'll have a main manager, and the main manager is the one that like, or the main system, whatever you want to call it. I might rename these to systems. I keep going back and forth. They're the one that will have the list of all of the subsystems, and they'll run the subsystems when necessary. So like, if we don't have any view commands, don't run the view manager. If we don't have any edit commands, don't run the edit manager. Like, so we'll be doing more of an ECS process once things get out of the Godot land. But we're still settling on some pretty core considerations here. I still need to understand how this works better. That's what I'm going to do tonight, because we're kind of getting towards the end here. The end of the stream here. I got to go to work in a few minutes. Appreciate everyone hanging out, though. This has been a nice stream, even though it's been mostly just me kind of bashing my head against the wall here, understanding. I feel like I'm really close. I feel like I'm very close to understanding how we're going to actually implement this. tonight I'm just gonna pour over it and try to mock up some stuff. Because as soon as we figure this out, as soon as we figure out our identification and our storage stuff here, we can really start to get cooking. And I really want to get cooking on this because our first goal is to just recreate the behavior that we have elsewhere. The existing behavior that we have in Godot, the ability to like draw our ships. And we need to be able to do that before we can really do anything else. Sorry, it's a bit of a shorter stream today. I got started a little late, but we'll be back at it tomorrow. I'm hopeful that we'll get a lot more done tomorrow, but I appreciate everyone hanging out and hanging through this pretty slow period with me here as we get back to the more juicy stuff very soon. And yeah, thank you all so much for watching. And I'll see you next time. Bye.